Okay, good morning, everyone. We start, it's 11 questions. I got one question from one of your classmates, it's number 19. Please, if you have any other questions, feel comfortable to put them on the chat. 20? Okay. So I have 19 and 20. Do you have any other questions? Oh, okay. 13, 20, and 33. All right. And 43. Okay, so we're gonna start. I will start by order. I will start with number 13 and we get going. So those problems are mainly an application of the ratio test, which is gonna be actually very, very useful. It's the easiest test as a whole for the student to use and an extremely useful test. So I will start with number 13. As usual, if you don't see, it's not clear, you let me know. So number 13, we have the following series. Sigma, the sum of, it's 10 to the n over n plus 1 times 4 to the 2n plus 1. Okay. All right, so 10 to the n over the quantity n plus 1, 4 to the n plus 1, and my n is from 1 all the way to infinity. And you are going to use the ratio test. So to be able to use the ratio test, we're going to start by identifying an and this term that comes after an, which is an plus 1. So what is an in this scenario? So an is the general term of my series. That's 10 to the power n over n plus 1, 4 to the power to n plus 1. Now, what is an plus 1? An plus 1, it means the term that should come basically after an. Everywhere there is an n in here, we should put n plus 1. And if we do that, we're going to have 10. Instead of n, I have n plus 1 over. Instead of this n, I'm going to put n plus 1. So I'm going to do it slowly the first time. So this becomes n plus 1 plus 1. And 4. 2n. Instead of 2n, I'm going to have the following. Instead of n, I'm going to have n plus 1 instead of the n, and that is the plus 1, which is going. Okay, please ask questions on the chat as you move on. All right, so now let us a little bit simplify n plus 1 because we have to take the ratio between them. But that's what the ratio test, the word come from. So n plus 1 is going to be equal to 10 to the n plus 1. There is nothing I can do about that. Over n plus 2. And this will become 4 to the power 2n plus 2 plus 1. So it's going to become 4 to the power 2n plus 3. So far, the only thing I did was, okay, the only thing I'm doing is just find the expression of an plus 1, and then I'm going to start taking the ratio. So we're going to take the limit. So that's the ratio that we call the rho. It's the limit as n tends to infinity of an plus 1 over an. Okay, so this is going to be the limit. As n tends to infinity, I will do this one slowly. The next time I will a little bit skip one step. An plus 1 is 10 to the n plus 1 over n plus 2, 4 to the 2n plus 3. Look a little bit messy. And the whole thing divided by an. which is 10 to the n over what? Over n plus 1, 4 to the 2n plus 1. Okay. As we did yesterday, we're going to use the property of fraction at this stage. And I'm going to write this as the limit, as n goes to infinity of the following. 10 to the n plus 1 over n plus 2, 4 to the 2n plus 3 times the reciprocal of the denominator, which is going to give me n plus 1, 4 to the 2n plus 1 divided by 10 to the n. And now, as I did yesterday, we basically have to simplify this expression. One way to make it a little bit easy for us to simplify is actually to put like term together. So I can actually, do it in an easier way. So this is going to give me the limit as 10 to infinity of. What do I mean by like term together? It's 10 to the n plus 1 over 10 to the n. I put them together. N plus 1, n plus 2 together, and 4 to the n plus 1 over 4 to the n plus 3. So let me put it like this, just because that will be easier for us to compute, times 10 to the n plus 1 over 10 to the n, finally times 4 to the 2n plus 1 over 4 to the 2n plus 3. Okay, now you guys start helping me out to see what we're gonna do. So this is the following limit. That's the limit. As n tends to infinity of. I'm not gonna touch this first term because I will know what's gonna happen to it. Now this one. 10 to the n plus 1 over 10 to the n. How much I'm gonna get? Remember, there are two ways you can do this problem. We're going to get 10, absolutely, because 10 to the n plus 1, this term here is 10 to the n times 10. That's really an easy way to see it. So this is going to give me 10. So my term is fully simplified. Now, 4 to the n plus 1 over 4 to the n plus 3. What is this going to give me? Anybody? I want to simplify. This is really, I'm getting 1 over 4 squared. Do you agree with her? 1 over 4 squared, I'm getting, that's absolutely correct. And let us make sure, yes, yes, yes. So this is going to give me 4. So you have two ways to do that, as I said yesterday. One way. It's 4 to the 2n plus 1 over 4 to the 2n plus 3. One way to do that is you use the property that's the same base, different power. You subtract the power. If I subtract the power, 2n minus 2n cancel out. I will have 4 to the minus 2, which is 1 over 4 squared. So that's why, yeah, you can do it. Another way you can say the top is, the top is 4 to the 2n times 4. And this piece is 4 to the 2n times 4 to the power 3. So if you do it that, you get exactly what you guys told me, 1 over 4 squared. So it's not actually hard. It's just really putting things together. So finally, what is the limit? Okay, as n goes to infinity, I guess everybody should see it by now, n plus 1 over n, this term here, we know it goes to 1 when n becomes close to infinity. So what we are left with is actually 10 over 60. Absolutely less than 1. So now I computed the ratio. It means an plus 1 over an. This is going to give me a number which is strictly less than 1. So by the ratio test, and that's really what the ratio test actually. So by the ratio test, which is applicable now, so by the ratio test, the series absolutely converges. End of the problem. Okay. Any questions before we move on? All right. So let's move on to the second problem. You guys have asked me. So we did 13. We're going to look at 19 and proceed. Okay, so right here. When I look at number 19. All right, what does number 19 tells me? So my series is sigma of the following. Okay, my numerator is n to the power 100 times 100 to the power n, wow, over n factorial, and n equal 1 to infinity. Well, the numerator seems to be growing really fast. And denominator, I don't know. Do you think the series is going to converge or diverge? Let's see. Let's see what's going to happen to the series. I have no idea. So what are an? Always check an because we're using the ratio test. It's n to the power 100 to the power n over n factorial. So I really don't know if n is big or small when n is large. Anybody have a hunch whether n is going to be, if I take n to be like 100, do you think it's going to be a large number or a small number? Do we have any idea? If I take n to be 100, I'll have 100 to the power 100 times 100 over to the power 100 over 100 factorial. It's really kind of hard to judge whether those terms are large or small. Let's see what's going to happen to the series. Let's say n plus 1. So this is an easy n plus 1. Instead of n, I'm going to put that. Instead of 100 to the n plus 1. N factorial, n plus 1 factorial. Very good. So now let us compute the ratio. So now I want to compute when n is large, what's happening to an plus 1 over an. Okay. It means that's the limit as n tends to infinity of. Okay. So what is n plus 1? N plus 1 to the 100, 100 to the n plus 1 over the quantity n plus 1 factorial divided by n to the 100, 100 to the n over n factorial. So let us compute this limit. I'm going to compute this limit, but I'm going to try at the same time to put like terms together. So we're going to have n plus 1 to the power 100 over n to the 100. Then we're going to have 100 to the n plus 1 over 100 to the n. But this n factorial is going to go to the numerator here and the quantity n plus 1 factorial. So I skipped this step. Do you guys, is it okay? Can you follow? All right, let's compute this limit. What do you think we're gonna get? Anybody can unmute and tell me what do they want me to do? What we're gonna get? Okay, the limit as n tends to infinity of. All right, I will follow the middle term become 100. Right? That's the easy part. Now, this term here, do we know what will happen to it? Okay, what did we see yesterday? N plus 1 factorial, how can I write it? Basically, we're multiplying up to n times n plus 1. So this term is going to be easy because I'm going to factor out by n factorial. Very good. Now, this term. This is really a mess. What do you think I'm going to do to compute its limit? This one. The easiest way possible. Who would like to pitch in? So I have n plus 1 to the 100 over n to the power 100. How can I compute this limit in a really kind of nice way? Absolutely. Write it all inside the power of 100. I fully agree. So watch. This is 100 is a fixed number. It's not, it's a constant. So, and then in here, I'm going to put that. Now, I am almost done, and let's see what's going to happen here. So finally, I'll go one more step, and then I will start dealing with the limit. So I'm going to have the following limit. Okay, n plus 1 over n to the 100. I'm not touching it. I'm simplifying till I can't anymore, and then I start computing limits. 1 over n plus 1. All right, what's going to be the limit? I want answers on the chat. 0. Anybody agree with her? Absolutely 0. So what's happening here? Do you see how it's, so this term goes to 1. But I'm raising it to a power 100, which is a fixed number. It will go to 1. That's 100, 100. This term goes to 0. And then it means my whole limit is going to 0. So again, this is less than 1. The ratio test should remind you the geometric series. And I will want to tell you a little bit why it's looked like a geometric series. But for now, let us make sure we can handle those problems. But the ratio test reminds us of the geometric series because there is a reason why it does. And I will explain that later. So this goes to 0. So now the ratio, since my ratio is less than 1, so this is, sorry. Since the ratio is equal to 0, less than 1, so we have to know exactly what those tests tell us. The series sigma n to the power 100 times 100 to the power n over n factorial converges. It means actually, if we start adding those terms, I know they look bizarre, I fully agree, but if we actually start adding those terms, we get some. I mean, we get to a fixed number, n equal 1 to infinity. Okay. Now, I'm going to ask you the following questions. Okay, of course, related to this problem. What can you say about those terms? If I take those terms, what can you say about the limit of those terms as n goes to infinity? All right, I will answer this question, Christian. Does the ratio test apply for all types of series? It has a problem when the ratio is 1. And that's what number 43 will address. Okay, so question. I give you a minute to think about it, and you tell me. What's the limit as n tends to infinity of those terms? If I take n very large here, and I compute this, what type of terms are we going to get? Large or small? Okay, you guys have a minute while I'm having my coffee. So this series converge. What does it tell me about those terms? Anybody? That's going to be the limit of those terms. The limit, okay, anybody else? All right, I'm having two contradictory answers. We have to take care of that. Okay, I have alternating answers. 0 large, 0 large. Anybody else? Who can give me the argument? All right, now I'm back to 0. Am I gonna go back to large? I want you to think through that. The series converge. What does it tell me about the term of the series? Absolutely. The limit is going to be a 0. I know it's counterintuitive. I know that it's not really a trivial matter why the limit is going to be equal to 0 if the series converge. If the series converge, it means the term will have to become small, because if those terms becomes large, remember what we said, you will be adding, if those terms, let us say the an become close to 1, let us say, when n is large, you're going to be adding 1 plus 1 plus 1. The series will diverge. So limit of an is equal to 0 because the series converges. Because this series actually converge, it means the terms have, not the sum. I don't know much about the sum. I know that the sum will get close to a fixed number. I don't know what it is, but what I'm telling you what happened to the terms, because the series converges. It means those terms, even though it's really, we have no deep understanding, become very small. And the reason is n factorial grow very, very fast, faster than anything you can imagine. It means if I put here 100 factorial, it's going to be a huge number. It's going to be larger than 100 to the power 100 times 100 to the power 100. If I put here 1,000 factorial is huge, and it's going to take over almost anything to put in front of it. So the idea here is that factorial grows very, very, very fast, and that's why this series ended up convergent, because those terms are going to become eventually very small. Okay, questions please every time I'm saying something. So I finished answering your question, and then I'll give you an idea why the ratio test look like the geometric series. Not the geometric series, it looks like it, and the question is why. And we will address this question very soon. So I still have 2 problems to look at, and then we proceed. So 1, 2, 3. So this number 20. 20 is not, it's just not hard, but it's a good practice with notation of factorial. So number 20. Number 20. So I have the following series: sigma n equal 1 to infinity of the quantity 2n factorial over the quantity n factorial square. Okay, so it's really a good problem in terms of juggling factorials. So I'm going to start with a n. It's the quantity 2n factorial over n factorial square. But there's, okay, before I do that, there is usually when I assign those type of problem to the student, I see the following tendency. So before I actually proceed, I'm going to ask you the following question: true or false? True or false? Is this, can I pull the 2 out? True or false? So I want you to answer the question. Can I pull the 2 out? No. Anybody else? Crucial. Absolutely no. Okay, because let's take just a simple example. Suppose I take n to be, for example, 4. 2 The quantity 2n factorial, you're talking about 8 factorial. Just compute it. It means 1 times 2 times 3, etc. 2 times n factorial, it means 2 times 4 factorial. Now 2 times 4 factorial, that's easy. The 4 factorial is 24. That's going to give you 48. However, this is 1 times 2 up to 8, which is very different. So we cannot pull the 2. So we cannot really play with factorial the way we want. We have to be very careful how we work with it. So this being said, what's n plus 1? Instead of the n in here, I'm going to put n plus 1. And I'm going to put bracket factorial. Just to emphasize the fact that's the whole term. Instead of n factorial, I'm going to put n plus 1 factorial. Sorry, the whole thing squared. So what's this equal to? All right. So an plus 1, I'm going to distribute here. So that's 2n plus 2 factorial. And this one is nothing more than the n plus 1 factorial, the whole quantity squared. All right. With this being said, let us compute the ratio, as we always do. So what is the ratio in here? It is the limit as n goes to infinity. Now the ratio test tells you take the absolute value. Most of the series we're working with today, most of them, the terms are positive. So I don't have to worry about the absolute value. But if the terms are positive, negative, then the absolute value is in order and we have to put. So what's the limit here? The limit is, okay, let's see what we get. An, it means 2n factorial over n factorial squared over an plus 1. So I'm skipping a step here. I hope it is clear. You guys don't skip. I skip. Now, an plus 1, by flipping the denominator, is going to give me that. And this is going to give me 2n plus 2 factorial. Now I'm going to put things that look alike together, and then we're going to see what will happen. So n plus 1, so I'm going to put like the 2n factorial over 2n plus 2 factorial together. And I'm going to times it with, let's see, I combine those two. Now I'm going to put those squared over n factorial squared. And now we have to be very careful. It looks kind of complicated, isn't on top? Oh, I'm absolutely right. I'm sorry. Thanks, Tim. I will redo it totally. That's what happens when you go fast. All right. I flip them around and I would lose everything. So my apology, I will repeat the problem. So rho is the limit as n tends to infinity of an plus 1 over an. Okay? Basically in absolute value, but because all my terms are positive, the absolute value didn't matter. So that's the limit as n tends to infinity of, okay, over n plus 1 factorial squared divided by 2n factorial over that. Okay. So it's going to be equal to the limit as n tends to infinity of, and now 2n plus 2 factorial over 2n factorial times what I'm going to have here, n factorial square over n plus 1 factorial square. Okay. And now my job is actually to really make this a little bit simplified. This is just a nightmare in the making. So let us see. N factor, n plus 1 factorial, I know how to relate them to each other. The question is to n plus 2 factorial. and 2n factorial. How can I simplify this? It means how can I write the quantity 2n plus 2 factorial in terms of 2n factorial? I'll give you a minute to figure it out. Because I need to simplify. I don't know the limit of those terms. I mean, I have no idea what's happening right here. Unless I simplify, I don't know. So my question is, I want you to find the relationship between 2n plus 2 factorial and 2n factorial. 2n plus 2 factorial and 2n factorial. Absolutely, I don't know where you got it from, and my answer is no to chat. You cannot factor out anything. Question. Actually, I'm addressing the answer that I got on the chat. So true or false? Okay, I'm addressing the question on the chat. True or false? Let us say I have n plus 2 factorial. Is it n factorial times 2 factorial? True or false? I want an answer. That's what I saw in the chat. Is it a true or false statement? It's absolutely a false statement. If you are in doubt, take numbers, because n plus 2 factorial, so it means you're multiplying 2 times 3 times all the way to n plus 2. That's what you are multiplying those numbers. You are absolutely multiplying them. But you take 2 factorial, it means you're taking 2 times 1 times 2 all the way up to n. Absolutely two different ideas. All right, now I back to my question. Who can find the relationship between 2n plus 2 factorial and 2n factorial? And I want it to be done mathematically correct before I interfere. I want you to think through that. So I'm asking this versus 2n factorial. How can we relate them? And to help you with that, I want you to relate 9 factorial to 7 factorial. How can you relate those two? No, the answer on the chat is also not correct. I want you to relate the easiest one, 9 factorial and 7 factorial. Who can relate them to me? Let's start with that, and then I move up here. Okay, this one. Who can find me the relationship? It is 7 factorial times 8 times 9. All right, is it correct? And absolutely yes, because what's 9 factorial? So 9 factorial is 1 times 2 times 3 times etc. times 7 times 8 times 9. That's the 9 factorial. Up to 7, that's the 7 factorial times 8 times 9. All right, that's what's 9 factorial in terms of the 7 factorial. Very nice. Now, will this help you a little bit figuring out this relationship? Remember, between 2n and 2n plus 2, there is 2 things. There are whatever. I want you to think about it. Okay, all right, now the chat is doing better. Anybody agree with what's on the chat? And I will explain it. All right. So 2n plus 2 factorial in terms of 2n factors equal to what? What's 2n plus 2? It means you're taking 1 times 2 times 3. And you keep multiplying. And the last term is going to be 2n plus 2. But my question to you is, what should come before 2n plus 2? What comes before 2n plus 2 is to n plus 1. That's what should come before to n plus 2. What comes before to n plus 1? It should come to n. What comes before it? To n minus 1. So now how are we going to write this? This piece is the quantity to n factorial times to n plus 1 times to n plus 2. Okay, so I'm going to rewrite it in a clearer way here. So this is what? It's 1 times 2 times 3 times etc. The last term in this multiplication process will have to be to n plus 2. So it means what comes before it should be 1 less than it, to n plus 1. What comes before it should be 1 less than that, which is to n. And what comes before it is 1 less, to n minus 1. So now I'm going to combine all those. Those will give me the quantity to n factorial, and then times to n plus 1 to n plus 2. That's the question. Okay? All right. So now I don't get the comment. All right. So now let us go back and connect everything. Now, this is the explanation of that. So this is going to become the limit as n goes to infinity of the following. So this is, all right, this is page 4. Okay, of the following. To n plus 2 is going to become the quantity to n factorial over the quantity to n factorial, now things becoming simpler, times n factorial square, it means n factorial times n factorial, n plus 1 factorial, this one we should be careful with. N plus 1 factorial is n factorial times n plus 1, but since it's squared, we're going to write it this way. Now we're almost reaching the end. To n cancel each other. So the numerator would leave me with to n plus 1 to n plus 2 times n factorial, n factorial, n factorial, n factorial, 1 over n plus 1 times n plus 1. And finally, this is going to give me the limit as n tends to infinity of the following. To n plus 1 times to n plus 2 over n plus 1 times n plus 1. Now you guys do the math. It's actually simple. The limit is going to be equal to 4. Distribute, and you're going to have here 4n squared. Here you're going to have n squared, which is going to be equal to 4. The ratio is bigger than 1. The series diverges. End of the problem. Okay, so this problem is good because it's really a very good practice in juggling notation of series. Okay, I know that I still have one problem hanging in there. Which one? 42. Sorry, I wrote them down. Okay. My memory is 43 part D. So let's look at 43. Okay, 43. All right. And the question here, for which of the following series is the ratio test inconclusive? That is, it fails to give a definite answer. So this problem is really telling us where the ratio failed. All right, so I will do part D because they're all actually the same. And this is my series. Now, when does the ratio test fail? Question addressed to all of you. When does the ratio test fail? It fails when the ratio is 1. So I'm going to take this series. So that's the square root of n over 1 plus n squared. And I'm going to try the ratio test. And tomorrow we're going to discuss actually strategies. So what to use what in every situation. But this is important to know, give us a clue when things will fail. So I'm going to try to use the ratio test. And let's see what happens. So an is the square root of n over 1 plus n plus 1 square. Sorry. Plus n squared. An plus 1 is the quantity, square root of n plus 1 over 1 plus n plus 1 squared. Okay, now let me compute the ratio. So what is the ratio in here? Of a n plus 1, I wrote it this time because I don't want to do it backward. So that's going to be the limit as n tends to infinity of an plus 1 times over an by flipping an over the square root of. So let us compute this limit, and I'm going to imitate what I did before by putting the square root together because it's easier. So I'm going to have square root of n plus 1 here over the square root of n because I can actually put the whole thing under the same square root. And this is 1 plus n squared over 1 plus the quantity n plus 1 squared. So let us compute this limit. So this is going to be equal to the limit as n tends to infinity. This one, I can write the whole thing under the same square root, so I can find the limit quickly. This is actually, I can distribute to n plus 1, so I know what's happening. It's going to give me, so distribute that. I will get n squared plus 2n plus 1. Add the 1, I will get plus 2. So what's this limit here? Immediately, the limit is 1 because these terms will go to 1 immediately. And this, if you divide by n squared, you know that, so you divide by n squared, you're left with 1 over n squared plus 1, you get 1, plus 2 over n, plus 2 over n squared. You guys do it slowly. This also will go to 1. It means the ratio is absolutely equal to 1. So the ratio is equal to 1. It means immediately, what can we say? Immediately, what can we say? In this case, the ratio test is inconclusive. It means in this situation, I have to try another test. It means another test is in order. Another test should be used. All right, sorry. Okay, so which test should be used? So I'm going to finish this problem. I'm going to ask you the following question. Which test do you think is the proper test for the series? Okay, here we are. So the question is, which test is the proper test, the correct test, not proper, sorry, is the correct test? Okay, so this is, I put again the series in front of you, and I want you to tell me which test do you think is the most appropriate. So my an, my general, that's a series of positive terms. So I have a lot of things to work with. I have the integral, I have the limit comparison, I have the ordinary comparison. Which test do you think will solve the problem for this particular sum? So you are faced with this problem. Which one do you think? Ordinary comparison, all right? What do you want to compare it with? Ordinary comparison, remember, it's not an easy test. Ordinary comparison, you're gonna requires inequality. Square root of n over n squared. So I'm gonna follow you. I'm not gonna write the answers. I'm gonna see what you guys are saying and then I write the correct answer here, because my plan today is to scan this stuff and give them to you. All right, so some students are telling me use the limit, the comparison, 1 plus n squared, and they are telling me square root of n over n squared. It means 1 over n to the power 3/2. Okay, which test you're using? Is it the ordinary comparison or the limit comparison? That's what my concern. The limit comparison or the ordinary comparison. If you're using the ordinary comparison, it means you have to justify that. So is this inequality correct? Is this inequality correct? 1 plus n squared is larger than n squared, correct? So when we flip it, it's correct. Okay, so we have to make sure we use the inequality hold. Now, my advice to you is, if you can use the limit comparison, it's easier than the ordinary comparison. And why is that? Suppose I take the following problem. I tweak it tiny bit. And instead of n squared plus 1, I will put n squared minus 1. Will the ordinary comparison, will the ordinary comparison work? It means, will this be correct? Yes or no? Absolutely not. So we have to be very careful with the ordinary comparison. So usually the rule of thumb, try to use other tests. Ordinary comparison, use it as a last resort, because a tiny change is making the ordinary fall apart. Okay, so for that, for this problem, I will actually use the limit comparison. And I ask myself, when n is very, very large, what's really going on? That's the square root of n, and that's n squared. It means if we do a little bit of algebra, n over 3 to the power half, and this is my Bn. And now I use the limit comparison, and I compute the limit of the ratio. And if you guys compute the limit of the ratio, you're gonna get actually 1. I will not do everything. And now by the limit comparison test, since my limit is not 0 and my limit is not infinity, the limit comparison test tells us that it applies. That's step number 1. So since sigma Bn converges, being a P series, P equals 3/2, it means my original series will also converge. Sorry, you guys should tell me to pull up my paper. Okay, so that's how we handle this particular problem. So the ratio test is actually extremely useful test, but it has issues. Every test has an issue. And the ratio test has an issue when the ratio is equal to 1. That's when we have to resort to another test. And the guidelines are, whenever your series involves, that's the guideline. Whenever the term of the series involves only constant power of n, the limit comparison is the way to go. The ratio will fail. So I repeat what I said. If the terms of the series involve constant power of n, what do I mean by constant power of n? N squared square root of n, square root of n plus 1. If the terms only involve those kind of expression, limit comparison test is the way to go. The ratio test will always fail. That's the rule of thumb. The ratio test does a great job whenever the terms involve 2 to the power n, exponent 3 to the n factorial. So that's when the ratio test will be used. So the ratio test work in those scenarios, which will show up a lot. They are very important scenarios. And the limit comparison actually work when you have constant power of n, only constant power. The minute you have only constant power of n, that's where the limit comparison will work. And ratio will fail here. If you have 2 to the n, 3 to the n, n factorial, n times 2 to the n, if your expression involves that, then the ratio test will be the way to go. So that's how we're going to talk a little bit tomorrow about the strategy, and that's really going to be the ideas. When to use the limit, when to use the ratio. Now the integral test, you just stare at it and you ask yourself, can I integrate? First, it works only for positive terms, but you have to make sure you can integrate. If you cannot integrate, forget about the integral test. All right? So that's it for today. Actually, I had a whole lecture planned for today, but I want you definitely to be very comfortable with the ratio test. So what you're going to do tomorrow, there is still one idea. I want to talk about it. And I'm going to also put on Blackboard a page with strategy of integration, sorry, strategy to find when a series converges. So please print it out so I can go through it with you. And you will have it in front of you, which will make the process much easier. All right. Now, what I'm going to do today is all those problems I solved right now in front of you, I'm going to scan them and put them on Blackboard. I know that the videos are not working, and don't ask me why, because Blackboard it's failing on me, it's not downloading them. So I'm going to try today to see if I can put them on YouTube, sometimes this evening. I don't know why Blackboard behaved the way it behaves. Don't ask me that questions. Okay. All right. Any other question before we leave? Anything else? Put on the chat if you have any questions. It's helpful for everyone. Okay. I will be in my office hours right now. Please, if you have any questions, you can meet me there. Right. And as usual, I'll talk to you tomorrow, guys. Bye.